Hi YouTube, welcome to the MA Academy C Data Structures tutorial series. Now in the previous tutorial I showed you guys how to create a basic and a simple linked list. However, as I mentioned in that tutorial as well, that was not an effective or an efficient way of creating a linked list. So I only did it so that I could explain the different parts of the linked list and how to create it, how the nodes are stored and things like that. So in this tutorial I will show you guys how to create a function using which you can add new nodes to the linked list. So every time you call that function, it will insert or it will create a new node and it will put it at the end of the linked list. So let's get started. By the way, there is one thing that I wanted to mention is that I have created this website www.maacademytutorials.com, so feel free to visit it. Now in here, so the first thing that we do is we include the stdio and std.lib library files. This is what we need for this tutorial. Next, we create a structure and we call it node. So this structure will have two parts. The first part is a data, which is of type integer, and then there is the second one is a pointer. So it's a pointer of type struct node. It means that this pointer will point to a node. So we know that whenever we create a pointer, it has a type. So is it pointing to a character? Is it pointing to an integer? Is it going to going to point to a floating point number? So this one in here, it's of type struct node, which means that it is going to point to a structure of type node in here that we have created. So however, in here I'm just using one element for this one. It's called data. However, you can add more elements if you wanted. So you can say charc and you can say like float, num, things like that. So you could have added more if you want, but for just to keep things simple, I'm using only a data port, an integer, and then a pointer. So this is the minimum that you would need. So we need a pointer so that it could point to the next element. Otherwise, we would have no way of referring to the next link, so the next node. By the way, one thing I wanted to say that if some of these things that I'm saying right now doesn't make any sense to you, please watch my previous tutorial. In that I have explained all of these individually and in great detail. So right now I'm kind of going quickly over it. I'm assuming you already know these things. Next, we create this pointer and it's called first, and for now being it's not pointing to anything. It's we are assigning null to it. So right now it's not pointing to anything. So this first we will use it to point to the first node in the linked list. So that is what you would need. Next, we use this function in here. It's this function. I'm calling it insert last, and it takes an integer. So we can see that our structure also has an integer. So whenever we call this function, what it will do is that it will add an element and a node to our linked list. So if you keep calling it, it will keep adding new nodes to the linked list. So in here I created a diagram. So this is how our linked list will look like. So the first time you add an element or a node to the linked list, it will create one. Then you add another one. So again, it will be two. Then you add another node. This time there will be three nodes in the structure, and each one of them will have a data port, just like we saw, and it will also have a pointer. So the pointer will point to the next item in the linked list. So in here we can see that the first one, as I said, the first pointer in here, it will point to the first node. So we can see that it is pointing to this node in here. Then the next part of it, the first part of this node is an integer, and the next one is a pointer to the next node. So in here we can see that it has the address of 126, and we can see that the second node has an address of 126. So in real world, of course, the addresses are going to look very long and you're going to be very complicated. But just to keep things simple, I'm using the short integer, so 126. Next, again, this will have a data port and it will also have a pointer which will point to the next node. In here we can see that it's 124. So we can see that 124 is the address of this node in here. So the first pointer is pointing to the second, the first node is pointing to the second node is pointing to the third node, and the third node has a null in it. Why? Because it is the last node in the linked list. So if you want to know what is the last node in the linked list, we can know that by seeing that whichever node has a null inside it, or whichever node is pointing to null, it means that it is the last node in the linked list. So later we will use the display function to display the contents of the linked list. So we would use this pointer in here. So we say whenever you see that there's a null inside the pointer section of the structure, it means that we have reached the end of the linked list. So this is how the linked list will look like. So again, let's go to the code. So in here, this function, we are creating two pointers, and first one is called temp and the second one is called last. So we saw that I explained the first one. The first one will point, the pointer called first will point to the first one, a first node in the linked list, and the pointer called last will point to the last node in the linked list. So in here we can see that first will point to the first node and last will point to the last node. However, the first time that you create a node, so the first time you create a node, the first and the last, both of them will point to the first node. Then when we create another node, so we can see that the first one will point to the first node and this last will point to the second node, which in this case the second node is the last node, right? Again, when we create three elements or three nodes, so again the first pointer will point to the first node and the last pointer will point to the last node, and in this case is this one. So in here, let's go to the code again. So in here I'm creating two pointers. Then we use this temp to create memory inside the heap section of the program. So we use this pointer in here whenever we have to access memory inside the heap section. We do it with the help of the pointer. So in here I'm creating this pointer called temp, and I'm saying it's of type structure node, and in here I'm saying temp is equal to. So in here I'm using malloc. Malloc is a function that is used to create or allocate memory inside the heap section of the program. So again, let me open this diagram in here. So in here we can see that whenever we are executing a program, so the heap section in here, we can see that if you want to create or allocate space inside the heap section, you can do it with the help of a pointer. So in here you can see that I said the first pointer will of course point to the first node, the last will point to this one in here. I haven't mentioned it inside this diagram, but the last will point into to this pointer to this node in here. And as we are creating new nodes, we are doing it with the help of the temp function. So in here, let me open the code again. So it says malloc. Malloc creates a space inside the heap section. So in here we can see that this is the heap section. So whenever we are creating this node, so we do it with the help of the temp. So it creates a space inside the alloc. So it allocates this much memory in here, and the size of the memory is determined by this in here. So we are saying size of, this is a function that finds the size of a data type, and in this case it's finding the size of a structure. So in here it's saying the size of this memory that we are creating inside the heap section, it should be of the size of the node. So in here we can see that node has two ports. It has an integer and it has a pointer. So if an integer is 4 bytes and a pointer is 4 bytes, so it will allocate 8 bytes inside the heap section. We could have said something like 8, but in this case it will be static. And next time, let's say we want to add more data to it. So like now, let me go back. So we are using this right size of. The advantage of doing it is that if we have to change the structure, let's say again we want to add a character and we also want to add a floating point, so then we wouldn't have to change it because it finds out the size of it and it creates that much space inside the allocate. Otherwise, if we had typed something like 8, then we would have had to change it, right? So in this case, I recommend using this malloc size of in here. So it finds the size of the structure and it will allocate that much space inside the heap. Next, what we do is we are saying, so this structure in here has two parts, right? One is an integer and the other one is a pointer. So in here we are saying that temp data is equal to x. So whatever the user types in here, whatever number, it will get stored inside the data section of the structure in here. And then there is a pointer. So the first item that you create, of course, it will have a null. And for now being, as we create the new node, we are setting the data part and we are saying that then it should point to null. So why do we need it? Because in here you can see that whenever the first time that we create, it will have null. The second time that we create, it will have the address of the second node, but this one will contain a null. And the third time that we create, this null will be removed. It will point to the third element, and the third node in here will contain null. So in here, we are just saying as soon as you create a node, just point it to null. And whether that null will point to something or not, we will cover it inside this if else block in here. So we are saying if first is equal to null. So in here, we say that first is equal to null. So the first time that we run this program in here, the linked list will be empty. First will not point to anything. So in here, inside this, in here, we can see that first the pointer first is pointing to the first one. However, if there is no linked list, the first one won't point to anything, right? There's nothing to point to. So what we do, the first time you're saying if first is null, the first and last, they should both point to temp. So as I said, temp, we use temp to allocate a memory inside the heap section. So whenever we are saying this, it creates a node. So if you go in here, temp will create this in here. It will assign a value, and the next pointer, it will be empty. It won't point to anything. So the first time we say it in here, we said the first is empty, which in this case is the first and last, they should both point to temp. So in here, we can see that the first time, as soon as we create the first element, the first element, the first part of it will contain a number, the second point will contain a null, and then first and last, they will both point to the first node in here. So we can see the first and last pointers, they are both pointing to the first element. So in here again, if we go to the code, we are saying if first is empty or if first is null, if first is not pointing to anything. So whenever you are creating a linked list, of course, first won't point to anything. So that you have to first create the first element or the first node inside the linked list. So when you do that, both first and last, they will point to the first node. Next in here, we are saying if the first is not null. So if first is not null, what does it mean? It means that we already have something, right? Then this block will be executed. So it means that this is our second, third, fourth, or fifth element in the linked list. So in here, let's say we create the second one in here. So when we create the second one, so previously in here, we saw that this second element, the second section of this this structure was containing null. Why was it containing null? Because in here we said that whenever you're creating an element, the data section should hold a number and the next should contain null. So in here we can see that it's null. However, we want in a linked list, the first one should point to the second node, right? After you're creating the second node, the first one should do it. So in here you can see that this time the first one is pointing to the address of this second node. And again, as soon as we create the second node, the first part of it will contain the integer. And again, just like the first one had a null in here, this is the null, right? The first one. So the second one, again, it will also have the null. And with the help of null, this is how we know that we have reached the end of the linked list. So in a 2-node linked list, which this is the end of the linked list, which is why it has a null at the end of it. So this is what this block in here does. So we are saying the last next. So what does it mean in here? This one that says last next is equal to temp. So as I said in here, temp will create it will allocate space inside the heap section and it will create a node. This time we are saying last next should point to temp. So in here you can see that when we created this element, the first node, the first and second, they were both pointing to the first element. However, this time you're saying the next part of the last should point to the temp. So whenever we use temp, it means that we are creating a new linked list. So in here, we create this new linked list with the help of this code in here. We are saying temp, we allocate the memory, we give it a data, and then we say the next it is pointing to null. So this node is created with the help of this temp function in here. That this node that we see, it's created with the help of the temp that we created temp pointer. Now what do we say in here? We are saying the last next should point to temp. So previously last next in here was null. So we are saying this section of the structure, it should point to the new node that we have created. So first and last, they are both pointing to this node. So we are saying the next part of this should point to what? This new one that we have created. So that's why you can see that this next, so previously last was pointing to this one, right? However, now we are saying this next of it should point to this address. Previously was null. Now it's containing this 126. So we are saying it should point to the new temp that we have created in here. So next, the third line, what does it say? It says last is equal to temp. So what does it mean? So in here we saw that first and last, they were both pointing to this in here. However, this time you're saying last should point to what? Temp. So in here, last should point to temp. It means that this one. So last is pointing to temp, right? So we created this node with the help of temp, and now last is pointing to this. Let me explain this part again. So last next is equal to temp. So in here, if you're confused, so last previously was pointing to this section, right? So we are saying the next, so last has two parts, right? this pointer has two ports. The first is the data port and the second port is the address. So we are saying its next should point to the new temp that we have created, new temporary node. So you can see that this is pointing to 22, or this address in here. Then we say last is equal to temp. So it means that the last itself should also move. So in here we can see that this last is moving to the last node in here, to the second node to the node that we just created. So every time we create a new node, last will move to it, and it moves with the help of this line in here. Then we create another node. So how does it look like? So in here again, we create it. The process is the same. First one is created, second one is created. So in here again, this will check, is first null? Of course it's not null. Then we are saying the last next should point to temp. So in here previously last next, in here the next part of this so last is pointing to this structure, right? So this node in here, to this structure, it has two ports, the data port and the next port. So the next part of it is what? Null. So we are saying the null should be changed to the address of the new one that we have created. So we created this one, it has the address of 34. So in here we can see that it contains the address of 134. And then in here we can see that last is equal to temp. Again, we want the point as we create new nodes, so the last pointer should point to the last node. So in here this is the last node. So we can see that last is pointing to the last node. So the first time we created a node, because we saw that the first and the last is pointing to the single node. However, when we create the second node, we saw that the first pointer is pointing to the first node, and the last pointer is pointing to the last node in this linked list. Then we created another node. Again, we saw that the first one is pointing to the first node, and this time we saw that since this third node is the last element or the last node in the linked list in here, so we can see that the last pointer is pointing to the last node in the element. So if we keep adding more elements or more nodes to this linked list, this last will keep moving to the right, and it will keep pointing to the last node in the linked list. So this is what this part does. Then we use this display function, which I explained in the previous tutorial, I think. Again, it takes a pointer. So for this, we give it a pointer, and then you're saying if while p is not equal to null, printf p data, and then you're saying p is equal to p next. So what it means, it takes a pointer. So in here again, you're giving it the first. So it takes the address of the first data element. So in here we will give it the address of the first node in the structure. So it checks whether p is equal to null or not. P is not equal to null, right? So in here we can see that p has an address. P contains this element in here. So p is not equal to null. P is equal to, for now being, we say that 110. So what happens? In here we can see that if it is not equal to none, then print the data section of it. So in here we can see that this node has two ports. One is the data port, and then there is the address port, right? The next one. So we are saying print the data port of it, which in this case is 15, right? So it prints it. Then we are saying p is equal to p's next. So the first time you say display first, right? So the first time you are giving it the address of the first element. However, in the last line we're saying p is equal to p's next. What does it mean? So we said that p, this is pointing to this structure, right? It has two ports, a data port, which we printed in here, right? This prints that, and we are saying this time you're saying p is equal to p's next. So this address, it is equal to the next one. So the first time you ran, it was equal to 110. Now we are saying p is equal to what? 126. Then we check again for it. We are saying is p equal to null? No, p is not equal to null. P contains 126. So p moves in here. Then we are saying printf what? The data section of it. So if p is not equal to null, then give me the data of it, print the data section of it, which in this case is 22. Again, we say p is equal to p's next. So p moves to this one in here, which is 134. So 134 is this address, right? So we are in this node, and then is p equal to null? No, p is not equal to null. P is equal to 134. So this is where p is pointing to, this 134 in here that we see. So again, we are saying print the data section of it. So it does print 19, and then we are saying p is equal to p's next. So this time p's next, what is it? It's null, right? So we say null is the last node inside the linked list contains null. So in here we can see that p is equal to p next. So in here this time p is equal to null. So in here saying while p is not equal to null, but this time it is equal to null. So we break out of the loop. So let's again look at this. So we are saying we have 3 nodes in this. So again 15, 22 and 19. So again let me match these 2 numbers in here, 15, 22 and 19, and let me run this. So in here we run it. You can see that we are able to print it, and let me we can see that it works. So let me do a quick debug of it, right? So that you guys could understand it with the help of debugging. It might make more sense in case you haven't understood it. So it's good always to debug it. When you're learning something, I find it very useful when we are debugging things. So we set a breakpoint in here, and I say let's run it. So let's step into it. So the first time when we call this insert, you saw that I set that breakpoint in here. It calls this function in here, insert int. So we can see that there is the temp, which is null. There is the last, which is pointing to null, and then there is the first pointer, which again is pointing to null. So in here, you can see that we have these 3 pointers, right? There is temp, which is pointing to null, the last, and also the first. They are all containing nulls. Then, as I said, this temp will create a node inside the heap section. So let's step into it. So we say debug, step into. As soon as we do that, we can see that it has created it has allocated some space inside the heap section, and that space has an address. So this is the address of it. So in here, let me show you guys in here. So we can see that every time we create a node, it will be created inside the heap section, and the pointer will point to it. So in this case, it's first, because first will point to the first one. However, we are creating these pointers. We can see that with the help of temp. So for now being, this node we can see inside the heap section has been created, and instead of first, the temp is pointing to it. So the only way we can refer to this node that we just created would be with the help of the temp, which we are doing in here. And the next line says that temp's data is equal to x. So for now being, we can see that the data section of it is empty, and the next section of it has some random address. I'm not sure this address even exists inside this computer. So it's because it's very different from this address in here. Then I say step into. So we can see that step into x. So we saw that the first time we said that insert last, we said it's equal to 15, right? So now we can see that data section is containing 15. So this line executed that 15. Now we are on this line in here. So we are saying the next should contain null. So next is now pointing to this address. So as soon as we step into it, so now you can see that the next of it is not pointing to anything. It's saying null. Then we check first, is it equal to null or not? So the first time we run, of course, it will be null because the linked list is empty. So in here you can see that the first is null. So if it's null, it means that these 2 lines will be executed. So we are saying first and last, these 2 pointers, they should both point to temp. So temp in here has the address of this one in here, which ends in 3670. So this last is not pointing to anything, and first is not pointing to anything. You can see that they are saying both saying null. So when we create, when we execute these 2 statements, this first, which is null, and this last, which again is null, it should point to the temp address, which ends in 3670. So as soon as I step into it, so in here, let me step into it. So I haven't stepped into it yet. So yeah, this first, now you can see that this first is pointing to the same address that temp is pointing to, which ends in 3670. Next, when we step into this one, however, last is still pointing to null because we haven't executed this statement, right? So when we execute it, you can see that these 3, they are all pointing to the same node in here. Now the else is not true, right? So if first has been executed, it means else is not executing. So at this point, we are in this place. So we can see that first and last, they are both pointing to the same node. So in here, we can see that first and last, they both has the same address. So this won't be executed. So let's do a step into again. And then we call this, then we say insert is equal to 22. So we insert 22. So again, let's step into. So insert 22, let's step into again. So in here you can see that this time we are creating another we are creating another node inside the memory. So let me go in here. So the first one has been created. Now we want to create another one, which will be created inside the heap section again. So let's execute this line. So it said debug step into. So when it gets created, you can see that this time the address differs. Previously it was 3670, and since we saw in here that then we create another node, and it will, of course, it will have a different address, and it will have a different address, right? So the address of it this time ends in 2FC0. Now you're saying temp's data should equal to x and its next should point to null. So however, when we are looking at it now, data is equal to 0 and null is next is null. So in here, x should contain 22. So when we run step into it, so we can see that the data section again, now it has containing 22, right? Previously it was 0, and when we executed this line, because in here we are adding 22. Next, it's already pointing to null. So when we step into it, again, it is null. However, previously we saw that when we created this linked list for the first time, first was pointing to null. So the first time we executed this block in here. However, this time it's not true, because this time first is not containing null, right? First, in here we can see that first was already pointing to an address, the first element. So this time we will execute this couple of lines. So let's debug step into. So we can see that this block was skipped, and now we are on this line in here. So we said last next should point to temp. So what is last next pointing to? Last next is pointing to null. Why is it pointing to null? Because we have only one node inside our linked list so far. So in here we can see that this is pointing to null, right? This contains null. Now we want to add another element. So we are saying last next should point to the new temp. So in here, sorry, last next should point to the newly created node, which is temp. So last next is null. So as soon as we debug, so let's debug, step into it. So when we step into it, so you can see that last next has changed. What is it containing now? It's containing the address of newly created node. So in here we can see that the node address is 2FC0. So in here we can see that now it is pointing to the 2F0. So in here we can see that as soon as we do that, just like this 0x126 is the address of the second node, the same goes in here. So this is pointing to the next one. Now we execute this line in here, which is saying last is equal to temp. So for now being, this is pointing to the this next section of it, the pointer is pointing to the second node. However, the last pointer is still pointing to the first node in here. What we need, we want this last pointer to start pointing to the second node in here. So how do we do that? We do it with the help of this line, which is last is equal to temp. So last for now being is pointing to 3670, right? So 3670 is the address of the first node. So we can see that first in here is 3670. However, last should point to the last element. The last element is the one that we just created, right? So when we step into it, so now you can see that the last has changed. Last is now pointing to the newly created node that we did. So you can see that now they have the same address, 2FC0. However, the address of first is not changing because it will point to the first node. Again, when we debug, we step into, this time we want to add 19 into our linked list. Again, let's step into. So again in here, with the help of temp, we create a new node. So in here, the temp we will do. So as soon as I execute that statement, you can see that this address, which contains 2FC0, will change, because in here, as soon as we create this, so this node will have a different address from this node, right? So the address will change. So let's again execute it, debug, step into. So as soon as I step into this part of it, into this section, what happens? In here, you can see that the address gets changed. This time the address ends in 8340. Again, we say the data should contain X and it should point to null. So the temp that we just created it is data is 0 and it's pointing to some random address which I don't think even exists on this computer, because it's kind of very different from these addresses in here. So next, as soon as I step into it, you can see that the data should change from 0 to 19, because this is what you're inserting, right? And then we are saying next should contain null. So next is containing this number in here. So as I step into it, you can see that the next now it contains null. Then we move inside this if else statement. So is it saying first is equal to null? So first is not equal to null. We can see that first is already pointing to this 3670, which is the first node. So we won't execute these couple of lines. We will move to the else part, which is this two. Again, it says the last next should point to temp. So the last next, what is it pointing to? Last next is pointing to null. So if you look at this data structure, when we created two nodes, the last next is null, but we want this to change to what? The address of the new node that we created. So in here, let me look at this. So this new node that we created, it has the address that ends in 8340. So we want its next to point to temp. So currently, when I debug, I say step into. So last next should point to temp. Sorry, let me step into it. It wasn't in there. So in here, you can see that this time last next is pointing to 8340. So 8340, we can see that it is the address of the new node that we just created. So in here, if you look at it, this 8340, this new node in here, 134 is the same as this one because it's the address of the new node. So the same goes in here. So its next is pointing to the new node that we just created. So temp is equal to 8340, and the next of the last is pointing to the same address. And then we are saying last should point to temp. So for now being, we are in this stage in here that its next is pointing to the new element. However, the last is still pointing to this. Just like last is pointing in here to this second node. However, we want this last to move to the last node in the linked list. So for now being, how do we do that? We do it with the help of this last line in here. It says last is equal to temp. So in here we can see that last is currently not equal to temp. Temp has an address of 8340 and it's not the same. So as I step into it, so we can see that last is equal to 8340. What does it mean? It means that the last pointer has moved to the new node. Previously it was pointing to the second node, and now with the help of the last statement that we just executed, last has moved to the last node inside the element, inside the linked list. So again, so we are done with it. Next, I debug into it again. So we move to the display. So when we say debug step into, so again we move in here. So we say give it the address of first. So the first has the address that ends in 3670. So in here, is it equal to null? No, it's not equal to null. So it will show what? It will print the data part of it. So in here, if we do it, so we can see that the data part has 15. So when we step into it, so let's just step into it in here on this line. So we can see that 15 gets printed on a screen. Next, we are saying P should contain what? P is next. So P currently contains at the address of 3670. However, we are saying P is equal to P is next. So P is next is containing the address of 2FC0. So as soon as we execute this, P's address will change. This will change to 2FC0. So let's say step into. So now we can see that its address has changed. Now it's pointing to the second node. So again, when we step into, is it equal to null? So it's not equal to null, right? So that's why we are now printing it with this in here. So we said step into, and when we say a step into, you can see that 22 gets printed. And when we see it in here, 22 gets printed, the next line is saying that P is equal to P next. So when P is equal to P's next, it means that the P's next is containing this address of 8340. So if right now we can see that P is equal to this, so when we execute this statement, this address will change to 8340. So when we say step into, P has changed, right? So is it equal to null? No, P is equal to this address. It's not equal to null. So if it's not equal to null, so let's print it. So when we debug, it moves inside in here, and as soon as we execute this statement, we can see that 19 gets printed. However, this time you're saying P is equal to P's next. P's next is equal to null. So as soon as we execute this, so now P is pointing to what? Null. And this line says while P is not equal to null, so execute this statement, but P this time is equal to null. So if P is equal to null, this statement won't get executed. So this time when we say step into, we move out of the while loop, and our program has finished executing. Wow, this was a long tutorial. So I hope you understood this, guys. If you still have any questions, suggestions, or recommendations, feel free to put it in the comment section below. And if you found this tutorial useful, make sure to share it with your friends, and I'll see you guys in the next one.